Hello and welcome to this screencast about Terracotta DB running on AWS using Kubernetes. To begin with, you need to log in to the Docker store. I am already logged into the Docker store, and then you can look for Terracotta DB. So for AG Terracotta DB, once you get here, you can actually have a look at the description and then you can check out. I don't need here to check out because I've already checked out the Terracotta DB repository on Docker store. I can go to setup instructions though and start having a look. The basic instructions that are given here are using Docker and plain containers without any kind of orchestration. What I am about to show you today is how to deploy a full cluster with some clients and the management and monitoring console, also known as the TMC, in an AWS cluster. Let's get started and let's follow through the instructions on GitHub. There is a GitHub repository that is named softwareg/Terracotta DB Cloud that can help you with deploying Terracotta DB on Kubernetes. Let's choose AWS with Kops. I strongly recommend you to check out to clone this GitHub repository and then open an IDE or any kind of text editor to read the instructions. In my IDE, I have cloned the Terracotta DB Cloud GitHub project. I am currently reading the README from AWS Kops. Already exported two environment variables for AWS that are my credentials and my password. Now I can follow through the instructions for Kops. First, let's set up the S3 storage that we're going to use. Then we can give a name to our cluster. Make sure that you end it with local if you don't want to configure DNS. Then I'm going to choose my AWS zone. In this example, Canada. Then I'm going to ask Kops to create the configuration for a cluster in this zone with this name with 4 worker nodes. Those worker nodes will be fairly large, and we are going to use those worker nodes to run 4 Terracotta servers. We're not done yet. We will create an additional instance group, so over worker nodes, for the clients and also for the Terracotta management console. Now we are ready to create it. Even if Kops returned, the setup is not ready yet. We'll need to wait a few minutes before being able to use our cluster. After a few minutes, you'll be able to run Kops validate cluster and find out that your cluster is ready. As expected, we have 6 client nodes and 4 nodes reserved for the Terracotta server, for the 4 Terracotta servers. Let's now install the dashboard as explained in the tutorial. Once the dashboard is installed, we can access it using kubectl proxy. When asked to log in, you can just skip the sign-in process. From the dashboard, we can of course see our nodes, our worker nodes, and our workloads. For now, we don't have anything. Terracotta DB images are distributed via Docker Store. So the same way you logged in with your browser, you need to have your Kubernetes cluster log into Docker Store as well. Let's create a secret and send it to Kubernetes. Once you're ready, and you have set up your username, your password, and your email, you can log in to Docker Store. The secret is now created. To make sure that Kops can access the Docker Store images, let's write a simple test, and let's try to create it. As we can see here, Kops was able to pull the Terracotta server image. You can now delete this pod. It's now time to create the Terracotta cluster. First, let's create the config map that are going to hold the configuration of the Terracotta cluster. Then let's install a license. If you don't already have a license, you can go to terracotta.org website and get a license from there. Make sure to download a license for Linux. Once you have a license, make sure to have it under your root folder. Now let's create a config map for the license. We will also need storage for the FRS persistence. Let's create persistent volume claims. We are ready to deploy the cluster. Let's have a look at the dashboard. As you can see, all the resources are being created. One important creation is the cluster tool job creation. Because once the cluster tool has run, you have the guarantee that your Terracotta cluster is configured and also has a license, so it's ready to be used. Be confident that all your Terracotta servers are up and running. One convenient tool to check that everything is doing fine is the Terracotta Management Console, also known as the TMC. You should find an external endpoint availability for the TMC. I suggest you click on it, but probably you will need to wait a few minutes for the naming to be available. Once you can access the TMC, create a new connection. Click on Next and Next, and you should see all your Terracotta servers. Also, you should be able to see one Ehcache client and one TCStore client. What you can do from now is scaling the number of caching client and store client. I should have all my clients being started. Now let's have a look at the TMC. And as you can see, the TMC has found all the 25 Ehcache clients and the 25 TCStore clients. You can have also a look at the resource usage. You can also have a look at the caching overview and the caching charts. Similarly, you can go to the TCStore tab and have a look at the TCStore overview and also TCStore charts. We can also trigger a failover. In this example, we can see that Terracotta 1.2 is the active for the first try, and Terracotta 1.1 is the passive for the first try. To trigger a failover means that we are going to kill the active, and normally we'll see the passive turn active. Let's try this. Let's scale the Terracotta server 1.2 to 0. We have just asked Kubernetes to kill the Terracotta 1.2 pod. If we go back to the TMC, after a few minutes, as expected, you should see the Terracotta 1.2 server go offline, unreachable, and Terracotta 1.1 failover from passive to active. Of course, you can expect all the clients to still be running since the cluster remained highly available during the failover. So that's it. Thank you for watching and have fun using Terracotta DB.